let me start introducing one of our first speakers. Our very first speaker is Lou Rives. Lou is president of VersaTech Automation. He's the founding partner of VersaTech Automation. The company provides engineering and design build services for manufacturing and process industries and to the US Department of Defense. So I'm going to let Lou tell us about VersaTech and their technologies and the wonderful things that they're doing. Lou.
And to advance.
Yes, right. Just press this button. Yes.
Good morning. Appreciate the opportunity to be here to talk with you all today. My focus is going to be on data collection off the plant floor and kind of give you all a few ideas to think about. I know some of you all are just starting into this, and I want to just hit some high points that I think might give you some things to think about. So the presentation focus is going to be on staying competitive through capturing your factory data, planning for the Internet of Things, the connectivity of your front offices to your plant floor, quickly realizing profits through measuring OEE, that's overall effectiveness of your equipment, and sharing that data in real time. I'd like for you to visualize your data as a byproduct of what you're already producing. In creating your product, you've already invested in creating the data, and if you're not using it, that's not providing you any value. You can ignore your data, not getting value out of it. If you capture the data and analyze it, it'll help you reduce cost in your facilities. Another reason to do it, your competition is already starting to do this, and they're going to have a competitive edge on you. Just a little picture of what I'm saying. You got a production line, a work cell, producing a product. You're producing data. If you're throwing it away, it's not doing you any good. I recommend that what you want to do is capture that data, analyze it, and then make improvements to your process. So I want to give you some ideas to think about as you're planning on connecting your factory to your front offices. You know, the acronym IoT is the combination of your information technology, which is typically considered your front office, your business aspect of things, and the OT, which is your controllers, your PLCs, all the devices on the plant floor that producing your manufacturing processes. The IoT is the convergence of those two. It's not just a buzzword, it's a shift in technology. You know, we've got it everywhere. It's in your PCs, your tablets, your phones, anything like home appliances, your vehicles, anything with embedded electronics and application software, and then the connectivity of those to generate the benefits out of them. You'll see an acronym, IIoT. It's the industrial Internet of Things, and is focused on your plants and the connectivity of all your automation and communication in your industrial environments. I'd like for you to reflect just a minute. I know some of you are a little bit younger than I am, but if you can think or imagine back to your offices of the 1980s. We were just at that time starting to get PCs. They're unlikely that you had servers, and so if you were working on a project on your PC, you were working on a hard drive, and if you wanted to share that information, you printed it out, or you took this thing called a 3.5-inch floppy and took it down to your buddy, and he put it in his computer, and that's the way you were sharing data. Obviously today, quite a different environment in the front offices. We have servers, we have the internet. And unfortunately, I see too much of when I go out on the plant floors 30 plus years later, a lot of the plant floors are operating from an information standpoint the same way we were operating our offices in the 80s. So moving forward and connecting those plant floors and the front offices will give you, much better control and to monitor your data, allows you to do that much easier, organize the information. You get much greater consistencies in the results of the information. There may be some people in here that have regulatory requirements like pharmaceutical, very important for record keeping, and the access of that information anywhere in the world through your phones or your PCs that you're carrying when you're overseas. On a real-time basis, you can have access to that data. Some considerations as you might start to implement or are implementing the connectivity of your data. You want to look at the Ethernet that is out on the plant floor. It may have been implemented for the purposes of emails and communication with the front offices, and really isn't robust enough to accomplish collecting the data off all your equipment on your plant floor. So that needs to be studied. I would strongly suggest that you think in terms of standardization at all levels, at your PLCs or your HMIs, for your software, and your software on your plant floor is going to be moving to the server client-based software, and you need to think about standardizing, and by that I mean primarily standardizing on vendors, standardizing on particular protocols. Just because you've got Ethernet, there's a variety of Ethernet protocols. They don't all talk with each other. They can be made to. You can translate it. But to make it easier on yourself, I would strongly suggest you make an overall plan on standardization. Choose your standardization companies wisely. They need to be someone that can give you good support. You want to be able to pick up a phone and call and talk to them, maybe have them visit your site. So that it needs to be a strong organization that's backing up the vendors that you're choosing. You're going to have to educate your workforce. There's going to have to be an investment in that. There's a lot of changes in the technology, and probably your workforce isn't ready for that. So you need to invest in that. You can do that in a variety of ways. There's a lot of learning that's out there on the internet. You can do that through the companies that you may choose to standardize with. And of course, the university can help you with this too. That's going to be a big challenge for you. Engage professional support of those who have implemented this before to help you get started or continue to help you. Security is going to be a real challenge for you. And the challenge will be that as you move your data collection to your front office, there's going to be this somewhat of a conflict between your IT folks, your classical front office guys, and your engineers out on the plant floor. A basic concept with the IT guys in the front office is they want to keep up with the patches. Microsoft comes up with a patch every day. They're thinking, I need to get that patch implemented. So they're thinking about, I can shut down for a little while and get that patch implemented, and that's what I need to do. Well, your control engineer on the plant floor says, I don't want you to ever shut down my plant. And so you've got this conflict, and you've got to work through this. It's manageable, but just be aware of it. It's going to be a challenge that you'll face. Security is important. I'm sure I don't need to tell you that, but your information on your plant floor is just as important as the security of the information that's in your front office. There's a lot of help with that through antiviruses or patching, as I've mentioned. One of the things that you're going to run into with the implementations on your plant floor is you're going to be having several different softwares, and you want to make sure that as you update one of your softwares, they don't become incompatible with the others. I had some customers that have had some bad experiences with that to the extent of shutting a plant down. So be careful with that. I don't want to scare you with any of those things. You should embrace IoT and overcome these challenges. It will pay you big benefits. You can maximize your operations. Drive your decisions by the data, not by inclinations or gut feel. You look at your data and make decisions based on your data. And then, so importantly, being able to share that data in real time anywhere in the world. I'll help just a concept about how to visualize your plant from a data standpoint. There is a model that's out there. I'd encourage you, if you're not aware of it, to research this, get familiar with it. It gives you a good plan for how to think about your plant from a data standpoint. It's the ANSI ISA 95. I'll put a plug in for Purdue. It actually was originally developed by Purdue. The idea of this is to create a fairly simple view of your plant, and it applies to any type of production. It's very simple thought process. It's based on levels, and the levels are based on what's the focus of the management of the control at those different levels, and then what is the timing of the data at those different levels. There's basically 5 levels, 4 through 0. The 0 level doesn't really have any data in it. That's actually your process itself. But from the highest level of 4, which is your maybe your enterprise or at least your front office focus, down to through your plant, your manufacturing level. And just to kind of give you an overview, a picture of what this looks like, this is showing you the 4 levels of the communication part and how those interrelate with each other and share data. So looking at it, studying this standard, looking at this, I think will give you a good planning process, give you some good thoughts. It gives you the ability to communicate with in your organization and with your vendors about exactly the area that you're wanting to work on, and there'll be a commonality of thought processes. Now, once you have started down this road, there's a whole host of ways that you can use your data, and I'm just wanting to talk about one of them. And it's using a key metric called OEE that is very easy to implement and gives you quick returns on the collection of your data. It's just one of many, but it's a simple one to start with, and you'll without very much investment, you'll get a good return. It's a really easy concept. It's not new. It was started in the 60s, but it's from a mathematical standpoint, it's just the percentages of the availability of your operation or a piece of equipment, let's say in a simple form, times the performance of that, how are things operating in comparison to how they were designed to operate, and then the quality aspect. So that you have 3 percentages that you're multiplying together. Pretty simple math. But this will help you look at your processes, your existing processes, and be able to reduce cost without a lot of investment. It will also help you make decisions on where do I want to make my capital investments, my future capital investments. And you're basically decreasing your costs by increasing capacity of your existing processes. It's, I think, one of the best single metrics to use for production losses. It will allow you to benchmark your process. How well am I doing? How am I improving? Excuse me. Determine where those improvements need to be made and what capital investments. And it'll also give you an understanding of where you need to make schedule changes, training improvements, and preventive maintenance improvements. Just mathematically, those 3 percentages on a world-class basis, the best in industry, are typically running in the 85%. So if you hear somebody tell you, I'm running 100% OEE, don't believe them. They're not doing it. So world-class is somewhere in the 85% range. 60 is a nice goal for you when you start out doing this. What you'll find is you're probably not at 60. Most of the time when we implement and the customer starts looking at his data for the first time, he's probably in the 50s. And we just recently did an implementation at a plant on a production line. They were running about 55% when we first started, and they made a small change in their scheduling and determined that they had a incidental item on the line that was causing them a problem on shutdowns. And in about a month, they went from 55% to over 70%, and on a shift basis, they were saving about $5,000 a shift. It probably made an investment other than the implementation of the software and what have you, but to make those changes, I doubt that they spent $1,000. You can start with one machine. I would encourage you to do that. If you're not doing this at all, I'd start with just one machine, or maybe a work cell, or a production line. Don't start with your whole plant. You can show the rewards that you can gain off just one machine, and I think then if you're faced with funding constraints, that'll make decisions easier. You can do this manually. It doesn't have to be done automatically. I told you it started in the 60s, so obviously they were doing it manually at that time. But I would encourage you to use automatic data collection. It's very cost effective, and it'll give you real-time reporting and be much more accurate. The data that you're collecting is simple. You've got some very basic things. What are my good counts? How many good parts am I making on a percentage of all the parts that I'm making? What's my ideal cycle time? That one may be a little harder to determine. If you've got some older equipment, you may not know what it was originally intended to design speed, but you could do some simple time studies. Plan your production as far as what do I want to consider as downtime, and do I typically take out breaks and lunch and what have you. So you don't have a full day in your schedule, and that's your availability. But the real key, I think, in making quick improvements is determining what are the reasons that you're not running. You know, do you have something on the line that's causing you to go down, or is it a previous operation or a post-operation that's causing the problem? The way that you're going to implement this automatically is, again, not hard. You've got a PLC on your machine. You'll connect that through your Ethernet to a server. We implement, as a system integrator with Rockwell Automation, a product that Rockwell has called Factory Talk Metrics. I don't want to make this commercial, but that's the product that we implement. And I just wanted to give you some ideas of cost. So, you know, a project, just a simple project, will maybe cost you in the $10,000 to $15,000, $20,000 range. You're not talking about hundreds of thousands of dollars to do this. And the example I gave you earlier, I think the project was maybe a $25,000 implementation project, and as I said, they paid for that in a heartbeat when they found out a few of the things that they were struggling with. Through using automation, you get these types of reports immediately. So that's a benefit of instead of doing this manually. And just other dashboards, and how do you present this data? You want to make sure you get this data to all of the team members. You know, this can be done on dashboards, out on your plant floor, on your PCs, on your phones. So you want to share this data, you want to share it in real time. I think that's such a benefit of it. Most of the plants that we deal with, certain key items that they want to know how things are doing generally are reported through emails to key personnel 24 hours a day. So they know if something's starting to trend in the wrong direction, they can quickly address it and resolve it and not lose a day or two of production. Just a visual of how you might share that data. Now, there's a whole host of other types of implementations that you can do. The OEE is a simple one to start with, but you'll want to be thinking about historians to allow you to do trending of all your operations. Track and trace is a really important thing, especially we deal with a lot of automotive plants, and they need to know where all of the materials came from that went into a particular component. You're going to want to be thinking about server, client type of HMIs, I would suggest. And one of the areas that I would really strongly recommend that you look into are the use of thin clients and thin managers instead of using the classical HMIs that are independently out on machines. A great benefit with using thin managers and thin clients is a thin client is basically a fairly dumb terminal. And it's being operated by a server software. So imagine that you typically, in your plant, you've got HMIs out on your machines. What's displayed on the HMI is the operation of the piece of equipment. You've got a problem. A maintenance man shows up. He's trying to diagnose what the problem is. He's either carrying a laptop with him or he's got to go find the schematics to help him diagnose what the problem is on the machine. Well, instead of doing that, if you've got a thin client there, he just puts in his password and he gets a schematic on the same terminal that was being used to operate the equipment. So thank you for, I know this was quick. I could speak for hours and hours. She's telling me I got 1 minute left. But if you've got any questions, I'd be glad to answer them. I'll be available today. Jason Riley is with me today. He's over at this table. Jason. Jason's with Rockwell. If you've got any questions about their products, he'd be glad to help you. And I'm sure you'll be able to get my phone number and I'd be glad to talk with you, help you out, and just have conversations about these types of things. Thank you very much.